In this video, we are going to be talking about coterminal and reference angles and how to find them. So first, an angle is formed. I know we talked about in geometry how you find an angle, but in the case of when we put this into the coordinate plane, an angle is formed by rotating a ray about its endpoint. The starting position whenever from here on out is when we talk about the initial side, and it is always in the positive x direction. So the initial side is always in the positive x direction. That always starts the initial side, and then whenever you rotate that ray around, you will come to the terminal side, and that is how we would be finding, for example, the angle theta. There are positive and negative angles. So whenever we have a coordinate plane, and of course we always start on the initial side, which is the positive x, always start in the positive x. When we rotate counterclockwise, we are rotating around a positive angle rotation. So when we start and we basically rotate to the left, we create a positive angle. If we start on the initial side again, which is the positive x direction, but we go clockwise, which means we start, well, can't say to the left, I'm sorry, because that would be to the left too. When we start and we go in a clockwise direction instead of a counterclockwise, it will create a negative angle. So for example, this is the initial side, this is the terminal side, because it rotated. We started here and we rotated counterclockwise and we went 120 degrees for theta. But if you take the same position that it is in quadrant 2, in that exact same position, but let's say we got there by going clockwise, we have created the same position. It is in the exact same terminal position, but we went in the negative direction. How did we know we went negative 240 degrees? Because one full circle around, if you go from initial side all the way to initial side again, you will have gone 360 degrees. So if we went 120 by going counterclockwise, then if you subtract that from 360 degrees, we would have gone negative 240. So if you take 120 and subtract from 360 degrees, that is how you would get the clockwise position of the negative angle. And so these are considered coterminal angles. Coterminal because they end up at the exact same terminal side, but they got there by two different ways. So anytime you find a coterminal angle, if you add and subtract 360 degrees, you will be able to find a new coterminal angle. So for example, here are 3 coterminal angles. Let's say this is the terminal side right here. Well, we can get there by going 45 degrees. Or if we subtracted from 360 by going clockwise, then we would have reached it at a negative 315 degrees. Or one way else to do it is if we started and we went counterclockwise, but we went all the way around the circle, which is 360 degrees, and then went our 45 degrees, we would have reached the terminal side again at 405 degrees. So basically, there are an infinite number of coterminal angles. You can subtract 360 degrees twice, 3 times, 4 times, 5 times, 6 times. You can add 360 degrees 5, 6, 7, 8, as many times as you want, and you can still reach the same terminal side either way by adding or subtracting 360 degrees. So for example, if I want you to find 2 coterminal angles to 45 degrees, the simplest way to do it is to first subtract 360 degrees, which would give you a negative 315 degrees. Another way is to add 360 degrees, which would give you 405 degrees. If you wanted to keep going, you could always add 360 degrees twice. And if you did that, you would have gotten 765 degrees. Or I could have taken 45 degrees and I could have subtracted 360 degrees twice, which would have gotten you a negative 600, I believe, in 75 degrees. So there are multiple coterminal angles that you could have gotten depending on how many times you added or subtracted 360 degrees. So same thing. I want you to attempt this one. So pause the video, attempt this problem, and then resume to see the answer. Okay, so one way to do it is to go ahead and add 360 degrees to it, and you would get 220 degrees. That is one coterminal angle. I could subtract 360 degrees from it again, and I would have gotten negative 500 degrees. So that could be two of my answers. If you got 220 degrees or negative 500 degrees, those would both be right. You could have taken negative 140 and added 360 degrees twice, in which case you would have gotten 580 degrees. So it doesn't matter. There are multiple ways to find coterminal angles in this case. Now, what if it is a radian? Now, we talked about that there is a conversion factor of pi over 180 degrees. Okay? If you were to double that, because we know 360 degrees is one full circle. Well, if you were to double that from 180 to get 360 degrees full circle, then if you double pi, you will go full circle. So in the case of going all the way around the initial side, starting at 0, and we know pi is 180 degrees around, so if you go around again, you actually go 2 pi. So if I look at this as 1/4 pi, all we have to do is add 2 pi to that, which would give us 9/4 pi, or 9 pi over 4. Or if I was to take the 1/4 pi and subtract 2 pi, then I would get a negative 7 pi over 4. Or I could add 2 pi again, and I would have gotten, I can't think, 17 pi over 4, I believe. No, I wouldn't have. 2 pi, yeah, I would have gotten 17 pi over 4. So in case of any radian measure, you are going to add and subtract 2 pi. So I would like for you to pause the video, attempt to do this problem of 5 pi over 6, and then resume to see the answers. Okay, so if we look at this as 5/6 pi and we were to add 2 pi, basically you take 5/6 pi, 2 becomes 8/4 if you were to find a common denominator, and you would get, that's not a common denominator. Sorry. Common denominator of 6 means that that would be a 12, because 12 over 6 is 2, and you would have gotten 17 pi over 6. To subtract, you would get 5/6 pi minus 2 pi, which means you would have gotten 5/6 pi minus 12/6 pi, which would have been negative 7 pi over 6. So either one would have been two coterminal angles.